All right, so we're going to work on 7.3 today, logarithms and logarithmic functions. So let's go through this step by step. How many of you guys have heard of a logarithm before? Maybe SAT, ACT stuff? Exactly. Otherwise, you're like, what the hell is going on? Exactly, that's my point too. So let's go through this, baby steps. So first, this 2 is what we call a base. And we already know this because we studied exponential functions, right? Where we talked about the base being a constant and the exponent is where your variable is. All right, so this 1 is the exponent. Okay, so 2 to the first power, what's that equal to? 2. Okay, what's 2 to the fourth power? I'm sorry, 2 to the second power. 4 to the third power? 8. Okay, but what if I wanted to find like 2 to what power is equal to 6? How do I find what that x would be? Because we only know the nice numbers where it's like, oh, 2 times 2, 2 times itself 3 times, like 2 to the third power. What if I wanted 2 to some power to equal 6? How would I find out like the x variable? How do I know the exponent? More or less what I'm trying to do is say, hey, fill in the box. How can I fill in the box? 2 to what power equals 6? Well, another way to say this is log base 2 of 6 equals what? Because we're asking for the exponent. What we're trying to find is the exponent. Okay. Hello. Cool. Thanks. So we have a new scene chart. Well, technically no, it's supposed to be at the end. You can just sit by Sophia today.
Can't sit back there.
No.
Can't see over here.
You're supposed to be, well, where Noah's sitting, that's where you're supposed to be. Yeah. And then, huh? I have you sitting in the middle, but like in the back.
Huh?
I have you sitting like in the middle-ish, but in the back. Like it's not the front row. It's my back row.
Like you mean middle row.
Well, I'm not letting anyone sit in the back row.
Yeah. 3 rows left, middle, top, back.
Okay. Cool. All right, so we're doing 7.3. All right. So let's see. What about 3? I'm gonna do another example. What about 3 squared? What does that equal? 9. Okay, so the way I was just writing it, where I said log base 2 of 6 equals question mark. It's log whatever your base is. So here my base is 3. Of 9 is equal to 2. Because the whole way I do this is 3 to the second power equals 9. It kind of goes in this loopy. Okay, so to answer this question of what exponent of 2 will give a result of 6, we need a logarithm. A logarithm answers the question of what blank of a given base will result in a specific value. Do we know what this will be? Fill in the blank. A logarithm answers the question of what? What'd you say? Exactly. A logarithm answers the question of what exponent of a given base will result in a specific value. Hallie, was that you? Yeah, see, fill in the blank, be attentive. I'll try to be a little more liberal with my points. So, we have the scene chart, so you are right here. Move this stuff out of the way. But yeah, you're right here. Which is all the other people in your row are gone. Like this is the front of the room, so starting from the right side, going to the left. So technically, like Noah's in the wrong spot. All right. So let's explore logarithms. All right, so we have the base and the exponent. So in exponential form, we have the base to an exponent equals some number. But in logarithm form, our base goes right under the log and our exponent's on the other side. So you do this like curvy part. So you start at the base, draw an arrow to whatever it equals, and then an arrow back to the number inside. So it goes 3 to the 2 power equals 9. both of these are what they're. Both of these equations are saying the same thing. So on the left side, if I have a base and I know what power to put it to, I can figure out what it equals. If I have a base and I know what it's going to equal, and I'm solving for the exponent, solving for the exponent is what a logarithm is. Okay, so let's try this. 2 to the 5th power equals blank. 32. This means log base, what should I put here? 2, because that's the base, log base 2. It's like it's a subscript, so it's like below it. It's not like I'm writing 2 right on the line. It should be like a little below. It's a subscript. Log base 2 of 32 is equal to what? 5. Because you do the little circle. Do you guys, I don't know what to call it. Like, you like circle around if you want to convert it. If you want to rewrite it in exponential form, you circle around. So, all right, let's try the next one. 4 squared is equal to 16. Okay, so how would I write this in log form? Do I volunteer? Lily?
Log base 4 to the 16th power equals 2.
Okay, good. That's exactly. So the way I would write this, the way I say this is the way you say it is log base 2 of 16. Oh wait, log base 4 of 16 is 2. So that's how we say it. It's not to the power, it's just the base is subscript, right? It's below. It's not at the regular level. So
I understand this.
Yeah.
Can you explain it again? Because I don't understand. I don't understand the log.
What log means?
Like how you know, like how you write it. I don't even know what it means. How you write it.
So it goes log is like an operation of whatever your base is.
So the base.
And then exponent. And this is what the like answer would be. What do you call it when you put something to a power like the answer? Like the.
So it's gonna be like you write log and then you take
Log to whatever base
and it equals the exponent
of a number is equal to exponent. So that's the basic way we write it.
Okay.
So this was my base right here. This is my base. Here's my exponent. Here's my exponent. And then this was the number it equals, the number it equals. So log base blah of whatever number is going to be the exponent blah. Okay. Let's try this next one. So we're going to go from log form to exponential. So how would I rewrite this? Hannah, how would I rewrite this? Exactly. 3 to the 3rd power equals 27.
How do you know?
So it's the little, it's like the arrows.
Oh, you write it backwards.
Yeah.
Okay.
So when you're going from log to exponents, you start with the base, go to where we write the exponent, and then go to the number. So it's helpful to be able to convert between them both. Okay. So the definition of logarithm, so that's more or less what I talked about. The base has to be greater than 0. Okay, that's the same rules as if when we're studying exponentials, right? We studied this exponential before. We said the base can't be 0. We said it also can't be 1. What's 1 to any power? 1, right? So that won't be an exponential function. So that's why our base can't be 1 and it has to be greater than 0. Also, the exponent has to be greater than 0. I'm sorry, not the exponent. The number I'm like trying to find, like the base to some exponent, whatever that answer is, it has to be positive, which makes sense. Remember how our exponential functions, like they're only above the x-axis when we were drawing them? Yeah? We don't remember that? Nope. Okay. So here's the graph. Here's exponential growth. Yeah? Maybe so? Okay. And so, okay, sorry. We had exponential growth. We had exponential decay. Do you see how all of the y values are literally above the x-axis? There's nothing below here. There's no y values underneath here. So that's why I'm saying that it's named x. I shouldn't have called it x. But what it's saying is whatever my base to the exponent is, whatever number it equals, it's going to be positive. And it is. Because look, all these numbers are above the x-axis. They all have positive y values. So that's why here, like this number has to be positive. We can't take log of a negative number. All right, so the answer, remember the answer to a logarithm is always, and what? What is the word? The answer to a logarithm. So whatever I'm like solving for, what am I solving for? Exactly, it's always an exponent. Good. So we're going to write each equation in exponential form, aka we're going to be like rewriting exponential, doing the whole like circle thing. So we'll do the first one together. How would I say this first one? Noah, how would I say this first one? 1a. How do I write it? How do I say it?
Log of 3 is the 5.
Okay. So the way you say it is log base, whatever the number is, of blank is blank. So for example, A, I would say log base 3 of 9 is 2.
That's exponential form.
This is not. Right now it's in log form. But I'm teaching you guys how to say it. All right, so to write an exponential form, Noah, how would I rewrite this? So you start at the base, go to after the equal sign, so I have 3 squared, and then you circle back. You circle back to the number. No. Log base 3 of 9 is 2, also known as 3 squared equals 9. Because remember, this 2 is going to be my exponent. This 3 is my base. Let's try the next one. Yes, you still have 20 minutes. All right. Let's try B. So let's try saying it correctly. Log base 10 of 1 over 100 is negative 2. Okay, so the way I would write this is 10 to the negative 2 power equals 1 over 100. So we're just practicing rewriting. That's it. See, you guys got this. Got this. Okay, should we try the third one?
Yeah, I don't.
You understand B? Okay.
Sure, but like it doesn't. I need to see that.
You start with the base. You go to the equal. Okay. Yeah. Okay. So how would I say part C? How would I say it? Yep.
Log base 3 times 7.
Close.
729 is equal to 6.
Log base 3 of 729 is 6. So if I want to rewrite this in exponential,
It would be
3 to the 6th power equals 729.
Wait, can you go back to A, please? I just looked at it.
Yep. Gabby, sit up, please. Please make sure you're writing notes. Take off your hood. Noah, take off your hood. Okay, just don't be like sleeping or not. Pay attention. All right. Let's go into example 2. Write each in logarithmic form. So how would I write this? So I have log. And this is why I was really trying to help you know how to say it. Because here is my 5 is my base. 3 is my exponent. So it's log base. What's my base? 5 of 125 is 3. Because if I would go back and do the whole little voodoo circle, whatever, I could rewrite this as 5 to the 3rd equals 125th. Cool, so this is what I started with. It's just like this little circle game. There we go, curve it around.
You have to put those arrows in the answer.
So the part that is the answer is the maroon. The purple is showing you how I got, just double checking. So, and up here, this is how I showed my work. All right, so in B and C, this is how I showed my work. Because, yeah, all right, let's do it.
Log base 27 and then times 3.
So it's not times 3, it's just
like 3
yep, exactly.
And equals 1/3.
Yep. So notice the 27 is subscript. The 3 is if I drew a line, it's on the same line. The 27 is subscript underneath it. All right, let's try the next one.
It's going to be log 6. And then it's
Log base 6 of.
and then it's going to be subscript.
Yeah. So you take the base, and that's what's subscript on your log. Your exponent is what is equal, and then whatever this number is on your exponential, that's what goes here. Okay, how are we feeling so far? Yeah, okay. It's a little better than. Well, I'm confident in your skills. I'm confident in your skills for this. This is good. Baby steps. All right, now we want to evaluate each expression. So how the heck would we do that? Well, let's rewrite this. Let's rewrite this in exponential form. So notice this doesn't have a equals some number. So I'm going to say equals y. So when I rewrite this, I have 3 to the y is equal to 243. So what I'm looking for is what exponent do I put 3 to in order for it to equal 243? Well, I know maybe what's 3 to the 4th? I have a calculator. So it's 81. 3 to the 5th? Yeah. So I can rewrite, this goes back to what we were doing yesterday. I could rewrite 243 as 3 to the 5th. And then I know that my exponent I was solving for was 5. Or you could go from, so this is the first way you could do it. The second way you could do it is you just keep typing in your calculator. You're okay, 3 to the 1st is 3, 3 squared, 9, 3 cubed, 27, 3 to the 4th, 81, 3 to the 5th, 243. So it shows you it's 5. Our answer is 5 because what we're solving for is the exponent. Yes? Okay.
Clearly the answer is 3 to the 5th equals 243.
Well, but that's evaluating is we want to find what number. So I'm trying to solve for what exponent would give me that answer. Because a log, the answer always is an exponent. When you're evaluating a log, the answer is the exponent. All right, so let's do B. So if I rewrite this in exponential form,
it will be 3 to the y equals 81.
yep. And we just did the powers of 3 over here.
So wasn't it 4? 3 times 4?
Yep. So literally 4 is the answer. When you evaluate a log, your answer is an exponent. Cool. All right, let's try the next one. Ooh, tricky trick. Let's see.
No way. Would it be 1/8 y equals 512?
1/8 to the y equals
512.
512. Okay, so this is tricky. So what if I rewrote these in terms of another base like we did yesterday?
Oh, multiplied by like 8 over 1 or something.
Yeah, so what if I said this was like 8 to the negative 1? Because 8 to the negative 1 is 1/8.
Huh?
8 to the negative 1. 8 to the negative 1 power is the same thing as 1 over 8 to the first power, which is just 1/8, which is what I have here. Okay, so 8 to what power is 512? Do we know? 8 to the first is 8. 8 squared, 64. 8 cubed. Calculator. Should bring your calculator to class every day.
It's
Type
wrong,
it
it's
in.
just not out.
Where's it at? Get it out.
Bring it back.
Expectations, you have it out for class. It's 512? Okay, so this is, I can rewrite this as 8 to the third power. But wait, I have this, like, this thing on the left side. I have 8 to negative 1 to the y power. So I have an exponent to an exponent. It's exactly like what we were doing yesterday. How do I simplify this? Multiply them. So I have 8 to negative y is equal to 8 to the third. If I have the same base, I can set the exponents equal. Because there's this equal sign, right? 8 to some power is equal to 8 to some power. Well, that means the exponents must be the same for them to actually be the same. So negative y equals 3. That means, what's my actual answer? Y is equal to negative 3, and that's right. So I'm not picky if you say like y equals negative 3, or if you just write negative 3 with a box around it. Either way, I want the exponent as your answer. Okay. Perfect. We have one more. Let's go, let's do it. Log base 1/6 of 1 over 216 is y. So to rewrite this,
It would be 1/6. The power of y equals 1 over 216.
okay. Miles, do you have an idea of how we could go about solving this? Like, what should I do? Mm-hmm.
So instead of like, so we could put it to negative 1.
Exactly. Let's list out our 6 to the first is 6. 6 squared.
36.
6 cubed, what's that? $216? Oh, okay. So this is equal to, let's see, 1 over 6 to the third. Because I solved for the 216, not the 1 over 2 to the 16.
So
I'm just gonna pause here. Like, I don't wanna like go on if you're like, what the heck did you just do?
like, and then how do you cross it?
Okay, but we're good with how I replaced 216 with 6 to the third. We're okay there. Okay, and then we're also okay with the fact that 1/6 is the same thing as 6 to negative 1.
Yeah.
Because that negative exponent just puts on the other side of the fraction. But wait, negative and an exponent flips it to the other side of the fraction. So I can do that I can do that for this guy right here. So I can say 6 to the negative third. Aha, I can rewrite this whole thing as 6 to the negative third. Because the negative in your exponent just flips it to the other side of the fraction. Okay. Let's simplify the left side. 6 to the negative y.
So they're both the same.
Negative y equals negative 3. So that means the exponent I'm looking for is 3. Awesome.
That one's a little more difficult.
So that one was a little harder, but like honestly, I think this is about as hard as I like really feel comfortable making you do. Like, because this is testing you with like negative exponents on both sides and like multi-step, but we did it together. You can do it too. All right, so properties of logarithms. Properties of logarithms. Exploring the properties of 1 and 0 as an exponent can lead to the basic properties of logarithms. Recall, any number raised to the power of 1 is what? Any power to the first power is? Itself. Turn to the partner next to you, give him a high five. That was great. That was a lot of people. You should be happy you know that. Oh, poor Miles got rejected. All right. And any number raised to a power of 0 is 1. Okay, sweet. So what is 2 to the 0 power? It's 1. So I write that as log base 2 of 1 equals 0. Yeah, because right, log base 2 of 1 is 0 because 2 to the 0 is 1. Okay, let's try the next one. 3 to the 0 is 1. So log base what? 3 of 1 equals 0. 4 to the 0 is 4 to the 0? 1. Get this over with. Log base 4 of 1 equals 0. Okay. So here this b stands for any base, any number. I could put in any number for b and this will be true. B to the 0 power is 1. So I can write this as
log b 1 equals 0.
Exactly. So this is whenever you have log base some number of 1, you already know what the answer is going to be, because any log, any number to the 0 power is 1. Okay, now let's talk about the exponent of 1. Were there questions over this? We went through like 3 different examples to prove to you every single time when you have a log base something of 1, it's going to be 0. Every time it's 0. When you have the 1 right there. Okay. Let's go on to the next one. All right, exponent of 1. What is 2 to the first power? 2. Okay, so how would I write this? Log base 2 of 2 is 1. Because remember how we rewrite it? We go 2 to the first power is 2. Right, that's how we would rewrite it.
Log, the next one's log base 3.
Log base 3 of 3 is 1.
Okay. So
Good.
The next one would be log base 4 equals 1.
Mm-hmm. So here, this b is standing for any number, right? I could put any number to the first power. It's going to be itself. So if I have log base b of b, it's going to be 1. So where this comes into play is if you're trying to solve a problem, it's like, 3 times log 75 of 75. Wait, we just found out that this, what's this equal to? Log base 75 of 75, what's it equal to? Huh? It's equal to 1, right? So I can cross this out and just replace it with a 1. What's 3 times 1? 3, right? So you now have this wonderful skill where you can cancel things out. Whenever you have log base a number of the same number, it's just going to be 1. Cool, and then that's the whole lesson. So once again, it's literally 7 problems in the last there's 4 more at the end. That's SAT, ACT, prep. So you guys have 5 more minutes. You can get going on Alex or your homework. We're going to spend next class going through a practice quiz, reviewing, answer any last questions on homework. So I don't think the practice quiz should take the full time, but that's a good opportunity to get participation points.